Good afternoon. Today I'd like to show you how to use Pandas and Altair to pull cryptocurrency pricing data from the web and then to draw a candlestick volume composite chart using that data. The slightly more detailed overview of my talk is as follows. So we'll first grab some tabular data from the web. This is a pretty useful function, and there are at least two easy ways of doing this and getting it into Pandas, into your data science pipeline. We will then create the commonly used candlestick plus volume charts using Altair and get very depressed. And then finally we'll dig into the Altair source code and also into the Vega Lite docs in order to figure out how to make our composite chart panable and zoomable. Right, okay, so let's just start. If I do a quick search on Google for Ethereum prices, one of the first hits I get is CoinMarketCap. And over here I can see there's a very nice table. And if I then interrogate or investigate the table using this inspect functionality, I should be able to see, let me just reposition, I should be able to see that table very neatly marked up as a table with a head, T-head with all of the headings and a T-body with all of the rows of the data. Just keep that in mind for later. So one very easy way of capturing this data is simply firing up your trusty Excel or whatever spreadsheet you prefer using, and just copying this HTML table and then pasting it right into that Excel, and you'll see that it very neatly captures the heading, and it also captures the columns separately, which is quite convenient. Now I could just have saved this as Excel or CSV and then load it up into Pandas. But I had a quick look, and it turns out Pandas has a few tricks up its sleeve. Pandas is actually able to read this data directly from the web. So let's get started. Okay, so up here I have my normal auto reload invocation. In this case, I'm going for auto reload mode 2. That means it'll just reload all modules that have changed every time I execute a new cell. And remember, that's because I want to keep as much as possible of my notebook code in a separate Python file. So let's just execute that with Shift Enter. So it'll execute and then move into the next cell. Right, and over here we're just doing our normal import invocations. I want Altair as alt and I want Pandas as PD. As you will have seen that by now, these are our common conventions when we import these packages. So I import that, and then I just give it the exact same URL where I found that Ethereum historical data, and I use the Pandas read HTML function call. Pressing Shift Tab will give me all of this help, and in here I see I can give it a URL or a file-like object. So it could have been an HTML file that I've saved to disk. Very importantly, I can give it a match regular expression. So it will, as you see here, it will read all of the HTML tables, but this is just a way for me to tell it to only read tables that contain this regular expression. I'll show you how I use that in a moment. There's also another parameter called, I think, attributes. And in there you can specify, there we go, attributes. You can specify a list of the attributes that should hold for the table. For example, if you know the HTML5 DOM ID, you can specify that. Fortunately, in our case, CoinMarketCap only has that single table on the page. Right, I know this from inspection. But just to play it safe, I have given it this, this string. And you'll see it says market cap over there. So it should, well, get this table. If there had been more tables, it would only have pulled down the table that contains that string. Okay, so let's go back to the JupyterLab. And then I also tell it, I ask it to please try to parse the dates in the first column. So we see in the first column we have dates in month, day, year format. Python is usually quite clever, or there are a number of Python libraries, and especially Pandas is quite clever at interpreting these dates and storing them in a more compatible format. And then, because pd.readHTML usually gives me a whole list of tables, I ask it for only the first one. So let's do that. Oh, it's done. And now we can have a look using our trusty .head call on that Pandas data frame, which only gives us the first few rows. I can see that very neatly it's found all the data. It's changed the dates into this kind of more ISO compliant year, month, date format. And over here I have the prices per day. So for each day I have the opening price and the closing price. So that's the opening and the closing. So that's where the price starts at and where the price stops at. And then I also have for the day a high and a low. Just to give you an idea what we want to do, this is a so-called candlestick chart with a volume at the bottom. So you can see here the candlestick is almost like a statistical error bar. I show it in green if the closing price was higher than the opening price. In other words, the price increased during that day. And then I also show the maximum and the minimum. And I just change the color if the price has gone down. And when I put all of that together, I get a chart like this, where I can, over any period and over for any frequency, for example, by day or by hour, I can see whether the price went up or down and what the max and the min was. And there are then people who think that they can use these charts to predict, what they should do and what the market is going to do. But we all know that's not true. Right. Okay. So now I have this data, and now just to make things a bit easier on myself, I'm going to rename a number of these columns. Why I do that is as follows. So if we now rename that, let's just open up a cell below this one by pressing B. Now I can, for example, do, let's have a look at this. So if the name had still been close star star, this would not have worked, and I would have had to use the key format. In other words, I would have had to do this. So because I like using attribute access, I rename them, but you don't have to. Okay, so now we've renamed that, and now just to make sure that everything's happened, yes, look, it's the same table. It's an in-place rename of these columns, and you can see that I've just removed the stars over there, and I've changed that space over there into an underscore, also that I can use normal attribute access. Okay, so as is usual over here, we use an IDE, a real IDE, to be able to write our code, because this gives us much better insight into the libraries that we're using. Okay, so let me just talk you through this code. So what we want, well, let's just see what it looks like. Kind of magic invocations over here. Let's just run that, and what do we get? So here we get a candlestick chart, and this is actually a candlestick chart containing the prices that we got from here. So that's up to date, and that didn't take a lot of effort. Although we look at the code in a second, I did lose some time figuring out the next step, but okay, we'll get back to that later. Right, so this function that I'm going to show you now returns the rule, and the rule is simply this thin line going from min to max. It returns the bar, which is the thick line, showing you the opening and the closing price, and it also returns the volume chart, which is this bottom chart over here. And then I just use Altair composition. I use to layer these two charts into a single chart, into a layer chart, and then I use this ampersand operator. Oh, that's not ampersand. That's the and, just the and. I use this this and I use to make a vertical concatenation between these two charts. So that's the same as using the vconcat function in Altair. Okay, so now let's just jump back a few steps and look at this function that I wrote. So it takes any pricing table that has these column names. So I could use this on CoinMarketCap. I could use this for any. I've just chosen Ethereum. That's what I like. But you could have chosen any coin on here, and the table looks the same. So you can use the same code to make charts based on that data. Okay, let's switch to our PyCharm over here. So what you see here is nicely typed Python code. You don't have to type, but I prefer doing this, just telling the type checker, or at least the IDE type checker, what's what and what's supposed to be what. So what I start with, I build up a base chart object. So that's in Altair. I take the chart and I set it up with my Pandas data frame. So you can set Altair chart up with more types of data, but Pandas is really convenient because it gets the types and the names and everything from the Pandas data structure itself. So once you have the data in Pandas, you don't have to worry about the rest. And then, because all of these charts, as you can see here in my notebook, they all share this common date access. That makes sense. I want to see my volume and all of my candlesticks I would like to see across the same date range and also the same date frequency. I can already tell my base chart that it should encode the date variable. So this encoding refers to this grammar of graphics, and it refers to the way that Vega also works with data and visual representations. So what I'm saying here is that in this data, I would like to take the date column or the date feature, and I would like to visually encode that as the X position. So that's what encoding means, and that's a fairly central concept in Altair and also in the grammar of graphics, is just defining how elements of the data map to visual characteristics. So this is an encoding, and this is one of the channels, is X, the X position, right? Now to build the rules, I take that exact same base chart, and remember I'm using this base chart because all three of my chart components use the same data and will use the same x-axis, and now I start deviating from that. So I say, okay, in this base chart, I would like to have a rule mark. So a mark refers to any visual element in the chart, and that rule is just that line going from min to max. So I would like to use a rule mark, and then I add additional encodings using this encode function. I say, well, you know what, my y channel, so the height, will use the low feature. So remember that in my data there was a open, high, low, close. Okay, just remember that. So I'm telling it that for the one, I have a rule now. So, and a rule has facilities for at least two vertical visual encodings, that's y and y2. So what I tell it is, well, take the low column from the data and map it to y. And over here I say take the high column from the data and map it to y2. And that will define the full vertical length of that rule. And what I then also say is I just set up my scale. The scale determines how the data domain maps to a range. So domain is the mathematical domain that the input data spans, and range is the visual, let's say the visual extent of that data. So for example, I can map numbers. If I have input range from 0 to 10, I can say map my input domain spanning from 0 to 10, map it to my visual range of colors from, for example, dark gray to white or something like this. So that's always what a scale does. A scale in Vega and in D3 is mapping from an input domain to an output range. You can try and remember this by remembering that, well, D goes before R. So input domain, and domain is a mathematical concept. So that's where my data comes from, and then range is what visual range it should employ on that visual encoding. Okay, and then I also can say in this case, well, I want you to label that axis with the label price. Okay, right, so that's the low and the high price. And then very interestingly, the color of that rule, remember it needs to be green if we went up, and it needs to be red if we went down. And to do that, I pass in a condition, an Altair condition. And what happens here is that that condition allows me to have a Boolean expression. And then if the Boolean expression is true, that will evaluate to this value. And if it's false, it will evaluate to this value. So these are the two colors. And it's just saying, well, if the opening price is smaller than the closing price, it means we went up. So that will be green. And if it's the other way around, it will be red if we went down. Right. And what happens here is that Vega will apply this condition to be able to determine how the color visual channel should be specified, right? So the data will come in, and the datum is just referring to, well, the current row in the data set, or the current bar that we're plotting, and this will determine the color. It's very neat, but you have to sort of apply that vectorized thinking again. Okay, then we do more or less the same for the bar. Remember the bar is the thicker part, but it's essentially the same, except that it's not using the high, the min and the max. It's using the opening and the closing. So we can use the short forms over here. We say, well, y is the opening price, y2 is the closing price, and again, color is the same. Okay, so now we have our rule chart, our bar chart. Now we need a volume chart. So what we'll see often on these things is that next to, or just right under the candlestick, we can also see, relatively speaking, how much of that coin, or of that coin was traded during that period that candlestick appeared. So you can, I guess, associate things with that. If there's a lot of volume, that's a very strong signal that the market is bullish or it's bearish. And if it's a very low volume, then there's not much you can say about that, or at least that's how I, as an amateur, interpret this. Okay, so let's just go back here. Right, so a volume is also, well, I'm just specifying the type here. That's optional, but I do that sometimes when I later need to introspect that object using PyCharm. Right, and over here, I would like my volume chart to be a bit, to be not as high, or well, let me show you what I mean. Over here, you can see that my volume chart is about, it's about a fraction of the size of my top chart. I just need a bit of volume over here. Okay, and then I want the bar marks here. Remember, the mark is refers to the visual elements, and I added additional encoding. In addition to in the base, I already have the date, which is encoded as the x coordinate, and over here I'm saying take the volume and encode that as the y coordinate, and that will then apply to my bar. And again here, very importantly, I specify my scale with 0 set to false, because I don't want to include a 0 in there. If I do include a 0 over there, what's going to happen is that these bars are going to be much taller. So that bar is actually already a very high number. Let's say 1 billion, or 1 American, 1 US billion. Now I don't want to see the whole 1 billion. I'm more interested in the relative heights over there. But it's easy to change. But in this specific case, I chose to set scale with 0 false, so it would do what I wanted. Right. Okay, so then what happens is I call that function over here, and then I got out the rule, the bar, and the volume. And then to compose these, I use the plus, which is the same as this layering. And layering means that they go in the same chart. So that's why the rules and the bars are now kind of appear in the same chart. And then I use this to do a vertical concatenation of the charts. This to show that it's equivalent. I could also have just done, this alt.vconcat, and I get the same result. Alternatively, I could have said hconcat. Doesn't make much sense, but just to show you how that works. Thing is, I want this down here so I can see what volume bar corresponds to what candlestick. And the shortcut for for horizontal concatenation is this, the pipe character, like that. There we go. Okay, let's just put it back. So it's that easy. Oops. Only problem here is that I can now hover, and I will get more details. I'll get the opening and the closing price, and if I hover on the line instead of the bar, I'll get the max and the min. And over here, I can also kind of hover and get the volume. But I would like to pan and zoom. Now, usually this is quite easy. Let's just to show you. So let's reuse these chart objects. I have a rule and a bar and I have volume. So usually I can just go volume and then interactive, for example. And you will see now I can do everything I need to do, which is quite nice. Right. The problem is that I would like both of these charts to go together. And this is now where the bit of complexity comes in. So I can also, for example, layer and go interactive. And that works. But nothing, well, you'll find that if you try this, you'll find that not much else works. Let's just try it just to show you volume interactive. And now I've made them all interactive separately, which I mean is nice. But ideally, I would like these to be synchronized. Okay, so let's just try one more. So I spent a bit too long figuring this out, but let's just see. Let's take the whole combination and go interactive. And now things start breaking because vconcat chart has no attribute interactive. Okay, right. So to be able to solve this problem, I had to go dig into the Vega Lite source code eventually. So I first went and using my IDE, I went and looked what interactive does. So I can just go on here and then in my case alt period, and it will jump me to that interactive. And I can see here if I do an interactive on a layer chart, it's actually only doing this on the first layer. And let's just see what interactive then does, and then we can see, well, interactive on the base chart, that is actually adding a selection mapping. Okay, so this is starting to get interesting. So having Googled around in the Altair source code, then you see, well, you know, interactive is actually shorthand for adding a selection which is bound to the scales. Okay, so this helped me on my way, but it didn't help me to solve the problem. I eventually had to go to Vega, or to the Vega Lite documentation, and over there I finally found an example. This is exactly what I want. So this is binding two charts just on the x-axis, which is exactly what I want. And the secret here was that they do add a selection to the first chart, which binds to the scales and is an interval selection, and this is what interactive is short for. But then the secret is that in the combined vconcat chart, they have this resolve member over here, which says, well, in case of the scale, you have to treat x as a shared scale. Okay, so now the trick was then just figuring out how to get Altair to spit out that Vega, and I think this is, as I said in a previous lecture, it's Vega heritage, or the fact that Altair is based on Vega is both. It's a double-edged sword. So there are often times when when it's to your advantage, and sometimes in cases like this, because you actually also have to understand how Vega works, and you have to understand the constraints of Vega in order to get your Altair code going. That's when you go, well, maybe a bit of a deviation from the API would have been useful. But okay, that's the price we pay for a whole lot of functionality out of the box, and also just the elegance of the API. Okay, so after some more Googling around and looking at in the Vega documentation, this is the solution I came up with. So the short form is this. So if I go, I made a new function called pan-zoom vconcat, and this takes as input, it takes the rule, the bar, and the volume charts. And what I want, let me just show you what the output is. That's the most illustrative, I guess. So there we call abc.pan-zoom vconcat. And let's just use the first method 0, and see what that looks like. And look here, we have our candlestick chart at the top, and we have our volume chart at the bottom. And the nice thing is I can now pan the one chart, and I can zoom in and out, and the bottom chart is nicely synchronized with that. And this is exactly what I wanted. Okay. So I implemented both, two methods. They're actually just the short thing. The one is a short version of the other, because I wanted to show you what's actually happening behind the scenes. So the short version is that I layer my rule, my bar, and then I use the interactive shortcut, which, as you will remember, simply adds that selection bound to the scales to the first layer. Then I vconcat it with the volume chart, and then on that combination, I add this resolve scale x shared. Now you'll see that looks that looks very similar to this over here. And how I found it was just purely by knowing what the Vega Lite spec wanted, and knowing that it was set on the vconcat, on the resultant vertically concatenated composite chart, and using my IDE. In other words, I just used the chart and started typing .resolve, and finally I found resolve scale x equals shared, and this will then generate that Vega spec. If we break this down further, what's actually happening here, see that interactive is short for making a selection, an interval selection that's bound to the scales, and then adding, you'll see here, I added it to the first layer of the layer chart. So I go add selection scales, and then only do I layer it with bar. And then finally, in the combined chart, remember that's the vconcat, and then I do that resolve scale invocation again, just to show you what that looks like. Well, not only that. So let me just open up a new cell down here, and I can then say combine to predict. And now I will get something that is almost identical to the Vega spec. And there's a bit much to look for here, but that resolve will be here somewhere. I found it previously, but I'm not going to waste your time right now. Okay, so let's see, what else do we have to talk about? I think the only thing that I wanted to mention still was that the spanning and zooming took me a while. But well, you now have instant access to it. And the only other unsolved mystery is I initially tried to embed this chart, or to layer it, in fact, to layer it on the stop candlestick chart, and Altair and Vega can do that. So you can have separate y-axes on the left and on the right, and I got that working. But the problem is that the output range of this scale is always the maximum of this plot. So there was no way for me to say, well, no easy way or no non-convoluted way to limit the volume chart to, let's say, this bottom part of the chart. What I wanted actually was something like this, where the volume chart is down here right at the bottom. But well, I could just say that's an exercise for the reader. Please let me know if you've cracked that problem. Right, so just getting back to the summary, we loaded tabular data from the web. That was pretty easy. So you can copy paste into Excel, or you can use Pandas to read the table directly. This is a pretty powerful functionality. This means if you find a data set somewhere, you can get it into Pandas, and once it's into Pandas, it's in your data science pipeline, and you can do magic. I then showed you how to use Altair to create these candlestick plus volume charts. And as part of that learning experience, we looked at the Vega Lite documentation to figure out how to tickle Altair to generate the Vega Lite that we actually needed to do what we wanted to do. And that was to make the chart pannable and zoomable. I hope you enjoyed that as much as I enjoyed making it, and I hope to see you soon. Goodbye.